So this is about your chapter 4. In chapter, not chapter 4, it is actually the outcome 4. In outcome 4, we are going to discuss about the objective, analyze the process management, because the scheduling also will come under how you are going to analyze the process. So after studying this chapter, outcome, you'll come to know how to apply the process scheduling algorithms. We have different types of scheduling algorithms, how the operating system will execute based on your need, based on the applications, okay, how the process is executed. If so many processes are running in the system, the operating system has to decide which process to execute first based on some algorithm. We have some algorithm for that. Okay, one simple thing I'll tell you. You are in ATM. Okay, you are standing in a queue. You are standing in a queue. How the thing is followed in ATM? The persons are standing in the queue. You know queue, right? You know queue. This is, for example, this is your ATM. All the persons are sitting in the waiting in the queue. This is one person, this is one person, this is one person. All are waiting in the queue. Okay. For example, a new person comes. Where you will stand? Where you will stand here? If a new person comes, where you will stand? You will stand here or you will stand here? This is your ATM machine. Already some 4 persons are standing. 1, 2, 3, 4. If a new person comes, tell me where he will stand. Will you allow him to go in between?
No.
Back, right? Fifth person. So if sixth person comes here, so after this one, he goes out, he goes out, he goes out. So the queue will be moving in. Same thing in the operating system also. This is like a processor or CPU. I call it as a CPU. So the first process is executed, come out. The second process, the third process, fourth process, sixth process, fifth process, sixth process, like that. Okay. So it will keep on. That is why it is called as what? It is called as what? Queue. I hope, do you know what is the queue means? Last in, first out. It is like, or first in, first out. FIFO, not FIFA. It is FIFO. FIFO means first in, first out. So what is meant by first in, first out? Whoever stands first will go out first. Will go out first. Okay. So first in, first out. So that concept is followed in queue. Similarly, in operating system also, we have so many process. So like how the persons are standing. So operating systems will decide which one to execute, based on some scheduling algorithms, Understand what I'm telling? There are a lot of scheduling algorithms are there. We'll discuss now. There are a lot of scheduling algorithms like first come, first serve, SJF, shortest job first, and then we have RR is round robin, and we have priority. So first come first serve, shortest job first, RR means round robin, priority. SJF means what? Shortest job first. So I already told you the what are the other name for process. What are the other name for process? Can anyone tell me? What are the other name for process? The process can also called as tal. What? The process is also called as what? Can anyone read it? The process is also called as
task,
what is it?
task, job,
I may tell as process, I may tell as task, or I may tell as job. Everything is related to process. So what is FCFS? FCFS means first come, first serve. So what is first come, first serve? You know, you are going to hotel, you are ordering something. If five persons are there inside in the table, so what the waiter, the serving person will do, whoever order first, they has to give it, right? So that is called as first come, first serve, like this ATM. Whoever comes first will get the CPU. So we have first come, first serve, shortest job first, round robin, and priority. And you have all these things which we will discuss here inside. And this chapter is very, very important chapter. You know why it is very important chapter? Because this you have in your what? Practical also. You have practical and you have assignment also. Based on this chapter, you have more mark for this outcome. You have practical. You have what? Assignment also. Yeah. So it is very important. So this chapter, please listen to me. If you have any doubt, so it will be asked in theory, it will be asked in practical, it will be asked in your assignment also. Okay. So I hope the introduction part, whatever I have given, you have understood what is meant by scheduling algorithms. What is meant by scheduling algorithms? So here we are going to discuss about the introduction. What is meant by CPU scheduling? What are the properties or what are the criteria which we call it as? The criteria is also called as what? The criteria is also called as features or properties. And the types of scheduling algorithm which we have. Okay, actually this is one thing. The types of scheduling algorithm. So what is mean by CPU scheduling? What is the scheduling criteria and the types of scheduling algorithm? Okay. So what is CPU scheduling? What is meant by scheduling? Scheduling, as I told you already, so you have the schedule for your timetable, that is for your course. So when is your operating system? The operating system is on Sunday 2 to 4, and then Tuesday 2 to 4, and then on Thursday we have 2 to 3. This is your schedule. Will you come in any other time for the meeting? No, la, no, you will not come. Yes or no? You will not come. Will you come in some other thing? So whenever you have the schedule, you are coming for the meeting. Similarly, for some other course, you have different. So likewise, in the operating system, we have so many processes are there, but the operating system will decide which process to execute in the processor, because processor is only one. See, like we have the lab A141. Here in this lab 141, so the time is allotted 8 to 10, one teacher, teacher A, 10 to 12, teacher B, and 12 to 2, teacher C, and 2 to 4, teacher D. Okay, so like that we have the schedule for each and everything. So here in a multi-programming operating system, the method for switching the CPU among the multiple process is called as CPU scheduling. I already told you in a multi-programming environment, the method for switching the CPU. Switching the CPU means what? What is meant by switching? What is meant by context switching? Moving from process P1 to P2, or going between P1 to P2 for this process. Sometimes P1 will execute and sometimes P2 will execute. It's keep on going. That thing is called as what? CPU scheduling. So what is the definition of CPU scheduling? Can you come out? In a multi-programming operating system, the method for switching the CPU. This is CPU. Switching the CPU among the process. The process may be anything P1, P2, P3, P4. I hope all of you understand why I tell P1, P2, P3, because it is each process will have the identifier. What is identifier? This 1, 2, 3 is the identifier. Okay. So what is scheduling? Scheduling is the operation of selecting a process which is to be serviced by the CPU. So here we have how many processes are here? How many processes are here? How many processes are there? P1, P2, P3, P4. But how many processors are there? How many processors are there? CPU, how many CPU is there? How many CPU is there? How many processors there?
One CPU and four process.
CPU and 4 process. So now scheduling means it is the operation of selecting a process. So there are 4 processes. So the operating system will decide which process to bring inside the CPU. If it is P1, if it is P2, if it is P3 and P4, that algorithm is called as what? First come, first serve. Because P1 is first, P2 is next, and P3 is next, and P3 is next. So it is the process. Scheduling means it is the operation of selecting a process which is to be serviced by the CPU or executed by the CPU. A good scheduling technique is very important in evaluating the performance of the system. So the operating system, I told there are many scheduling algorithms are there. The operating system will decide, okay, based on the need. Sometime it will use first come first serve. Sometime it will use round robin. Sometime it will use shortest job first. Sometime it will use priority algorithm. So based on the need, it has to change what algorithm it has to be done. So various scheduling techniques exist. They influence the performance of the computer system. So for example, if the operating system is always used first come first serve, sometime the performance will be late. I will tell you why. There are some disadvantage of first come first serve. Why means, for example, if the process P1 it takes, for example, 1 day. How many day? 1 day to execute. Then P2 has to wait, P3 to has to wait, P4 has to wait. For the waiting time for other process will be more. Or if P1 is executing for 10 minutes, then it is easy. Yes or no? For other process. So the various scheduling techniques exist that influence the performance of the computer system. So what is meant by CPU scheduling? What is meant by scheduling? Know the difference. So how the operating system performance is getting affected. Do you understand the introduction? What is meant by scheduling?
Yes, master.
Now, what is meant by CPU scheduling? Same thing. The switching of the CPU from one process to another whenever any one need in the process arise is called a CPU scheduling. Other than processing. Other than processing. The switching of the CPU from one process to another whenever any need in a process arise. So you are moving between P1 to P2. If the need is arrived, then it is called a CPU scheduling. In a multi-programming operating system, the method for switching the CPU among multiple processes is called a CPU scheduling. Almost same. Whatever the scheduling, this diagram see here, it is keep on repeating. Understand? CPU scheduling. See here, the same thing it is repeating. It's same. No need to study that. And this is important. What is meant by scheduling criteria? Already we discussed about CPU utilization, turnaround time, waiting time, response time, all those things. There are several scheduling criteria. How will you decide the scheduling? How will you decide the scheduling? Scheduling criteria are there. So the scheduling techniques, okay, how you will select. When selecting a preferred method, there are different criteria. There are different criteria. Based on this criteria, you will choose which one or which scheduling algorithm need to be used by the operating system. The criteria depends upon the particular situation and environment required. As I already told that the operating system will not always use first come first serve, will not always use SJF, will not always use RR, will not always use priority. Whenever it is needed based on that priority, when based on that particular situation, the operating system will choose the scheduling algorithm. For that choosing, we need this scheduling criteria. We need this scheduling criteria. Or you have to know what is the scheduling criteria. Scheduling criteria means it is also called as feature, or it is also called as scheduling properties. Scheduling properties. Just go through it. Features and then properties. Okay. Features and properties. So what are the scheduling criteria and what are the scheduling properties? Yeah, okay, fine. The main scheduling criteria we have five. The first one is CPU utilization. In this five, already you know what is CPU utilization, what is turnaround time, and then you know what is waiting time. Because you studied in chapter 3. Yes or no? What is mean by CPU utilization? CPU utilization is expensive. When it is expensive, thus, it should be busy at all the time. I told you CPU utilization means we have only one process. We have only one process. We should always make that process to be busy. We should always make that process to be busy. That is, ideally, it is said that CPU utilization should be 100 percentage. It should be 100 percentage. But practically, it is difficult to achieve. Yeah. Yeah. The performance, if I see, this is the CPU. See the time utilization of the CPU. It is not 100 percentage. How much percentage we are utilizing here? Can anyone see here? See, we have so many processes are running. Here I'm going to see the performance. This is called as performance criteria, scheduling criteria. The performance of the system is depends on this one. Now you check out what is the utilization of this CPU. Is it 100 percentage? Can you see on the screen? CPU utilization here. CPU utilization percentage. How much percentage it is? Tell me, dear. You can see my
Four.
screen.
Four.
Just keep on changing, right? But not more than 20. But not more than, see, sometime 3, sometime 8, sometime 5, sometime 18. See, now it is 1, 2, 3. This is the percentage of CPU. Its speed. Number of processes. How many processes are there? Some nearly 196 processes running now. And you know the threads 2400, not this much of threads is running, this much of process, this much of thread is running. Because see the process, see here process you are asking, Mr. Where is 195? If you come across, see this application is 6, background process is 74, and then we have this Windows process is 97. So it is so many processes are running at the background. So totally 194 process is running. So you have that all these application is called as user process. User process. We have system process and the user process. What is the difference between system process and the user process? The process which is created by the user. By the user. For example, this Google Chrome, I open. This Microsoft PowerPoint, I open. Teams, I open. Notepad, I open. This Task Manager, I open. This Windows Explorer, everything the user Kumar has opened, right? Whereas the other process for a Acrobat reader like Intel, this cleaner, something which is already running at the background, this Casper Sky, okay, all these processes are by the process which is created by the user. So what I want to tell you is, so this is the thing. The first one is CPU utilization. Always you should make that CPU utilization should be 100 percentage, but it is never achieved. It is never achieved. It is very difficult. Even if you open all the application also, it will be maximum 90 percentage. If it goes to 100 percentage, sometimes the system will hang because you need the resources for that. You need the resources for that in a lighter loads, and it is only active around 40 percentage of the time. Most of the time, see here, only 40 percentage of the CPU utilization will be active. What is CPU utilization? See here. disk memory, how much memory. See, I can enable to out of this 24.9 GB, only 7 point memory utilize disk utilization because I'm not writing or doing anything on the disk, so it is 0% something here. Whereas Ethernet, the cable transfer, data transfers here. So this is the performance history of your system. CPU. Let's check out the CPU, the clock speed. This is called as clock speed. 2.4 gigahertz or 3. What is the maximum clock hertz it can be? So what is CPU utilization? Always you should make the CPU busy. Always you should make the CPU busy. It should not be idle. So CPU time is very expensive. Why the CPU time is very expensive? If you leave the CPU for some time idle for some time, that means you are not doing any job. So it is idle. Okay, fine. Continue or repeat? Continue or repeat?
Continue.
Continue, Mr.
So what is meant by CPU utilization? So utilization means make it CPU always busy. How you are utilizing? How you are utilizing the CPU? That is the matter here. So always you cannot utilize for 100 percentage, but if you bring it to 100 percentage, it is really great. It is really great, but it's very difficult. Okay, so it is only active. It is only active around 40 percentage of the time. Okay, so next one is what? Throughput. Throughput means the total number of process that gets completed in unit time is called as throughput. Throughput means what? The total number of process that gets completed in a unit time is called as throughput. Throughput should be always high. It should be max. It should be max. Even the CPU utilization also should be maximum. It should be maximum. Throughput should be maximum. What is throughput? I'll explain you. See, for example, I have 10 minutes. How many minutes are there? How many minutes are there? Come on, dear, tell me how many minutes? 10 minutes. How many process I have? I have 10 process. I have 10 process. If each process takes one minute, if each process takes one minute, is it possible for me to complete 10 process? Do you understand what I'm asking the question? Totally how many minutes? Here, for example, I have 10 minutes. That is called as unit time. Unit time means what? 10. If I have 10 minutes of time and I have 10 process, now each process will take 1 minute. Is it possible for me to complete all these 10 process? That is my question. Is it possible to complete 10 process? You're not getting my
No?
here. See here. I have process P1 to P10. How many process are there? Totally 10 process. Okay. And I have how many minute? How many minute I have? Only 10 minute. So I have 10 process and I have the time is 10 minute. If each process 1 take 1 minute, process 2 take 1 minute, process 3 take 1 minute. Like this, process 10 also take 1 minute. Is it possible for me to complete in 10 minutes? Is it possible for me to complete all process in 10 minutes?
Yes.
Because P1 1 minute, the remaining time is
10
9.
minutes.
No, no. After completing P1, you will have remaining time is what? 9. Because P1 is 1 minute class and P2 1 minute class. So remaining time is 8. So like that, I'm able to execute all 10 process because each process takes 1 minute. Each process takes 1 minute. That means what will be the throughput? My throughput will be 100 percentage. Yes or no? My throughput will be 100 percentage because I'm able to complete all the process in a given time, in a unit time. Is any process is pending? Is any process is pending to execute? Here, I have 10 process. I told you each process will take 1 minute, and I have totally 10 minutes. Will any process will be pending to execute? Okay, I'll ask like this. I have 10 chocolate. Okay, I have 10 student. I have 10 chocolate. I have 10 student. If I give one chocolate to each one, will there be any chocolate in my hand?
No.
No.
No. I have given all chocolate to one student. So all student will get one chocolate.
Yes.
Yes.
That means I had 10 chocolates, so I have given all student one chocolate. That means I have 100 percentage complete, right or not? So throughput is 100 percentage. Throughput is 100 percentage. See the total number of process that gets completed. Total number of process. What is my total number of process? What is my total number of process?
10.
Here, tell me 10. Okay. So what is 10? In a completed in unit time. What is my unit time? What is my unit time? My
10
unit time
minutes.
is 10 minutes. Okay. Unit time is 10 minutes and the number of process is 10. I get completed. I get completed. So throughput, the total number of process that gets completed in a unit time is called as throughput. Throughput should be as high as possible. What is the percentage here? What is the percentage here? 100 because all process is completed. Now I have another question. I have 10 chocolate. Okay. And I have 10 student. If I give two chocolate to each student, is it possible? How many student I can give? I have 10 chocolate. 10 students are there. But I give two chocolate to each student. Is it possible?
No.
No. How many student can I give? 10
10.
chocolate? No, how I can give 10 student? See, I have 10 chocolates. I give two chocolate to each student, two chocolate to one student. How many student I can give? See, two chocolate to one student, two chocolate to one student, two chocolate to one student. I need to teach math here. Two chocolate to one student, two chocolate to one
5.
student. How many chocolate? 10 chocolate to
5.
five. So remaining five student is pending, right? Remaining five student is pending. You understand? So in a given time, I was able to complete how much? The total number of process gets completed only how much? 50%.
50.
Not 60, it is 50 because only half I completed. Yes or no? So throughput should be always, dear, I want to make you understand what is CPU utilization and what is meant by throughput. Throughput means how much process you can able to complete in a given time. In a given time. That is called as throughput. So if, for example, the unit time is 3. Unit time is 3. So I have 3 process. I have 3 process. If each process take 1 minute, then I can able to complete and the throughput is 100 percentage. And 100 percentage, yeah. And then next one, see, for example, if each process, I have 3 process, if each process take 3 minutes, then I can complete only one process. I can complete only one process and it is 33 percentage. Remaining 2 process will wait. So it is 33 percentage. That is called as throughput. Next, turnaround time. What is turnaround time? That the time span from submission of a process to the system until its completion. So for example here, um, P1, P2, P3, like this. So now I submit this one to the CPU. I submit the CPU to process P1. I'm submitting to CPU. So how much time it takes for the CPU to complete one process? That is called as turnaround time. The time span from submission of the process to the system. System means CPU here. Until its completion is called as turnaround time. The turnaround time should be minimum. This should be what? Minimum. See, dear, you have to understand which one should be maximum and which one should be minimum. Because you know why? See, this process should not take more time in CPU. Process P1 should not take more time in CPU. It should be always minimum. Why? Because it should give chance for the other process P2 and P3. So the turnaround time should be always minimum. Turnaround time should be minimum. You understand? The turnaround time for each and every process will differ. See, for example, what is the turnaround time for P2? It is depends on this P1. Next one, waiting time. Just now I told you what is waiting time for P2. The waiting time for P2 is how much time taken by P1 to complete. The waiting time for P3 is how much time they taken by P1 and P2 to complete. Yes or no? That is called as waiting time. The time spent by the process in different queues while waiting for the CPU is called as waiting time. It is called as waiting time. How much time a process is waiting in the queue? Is waiting in the, see, for example, you are waiting in the ATM. One person will take 2 minutes, another person will take 5 minutes, another person will take 3 minutes. So if you are in fourth person, so you know how much time taken by person one, person two, and person three. So you will calculate total how much time you are waiting, how much time you are waiting, and the response time. The time taken by the process in producing its first response after the submission is called as response time. Response time is how it is responding for executing or completing, producing the first response after submission. After submission. Once it is, for example, here, once P1 is submitted, how much time it is taken to respond or to complete this P1 is called as response time. So what are the scheduling criteria are the CPU utilization, throughput, turnaround time, waiting time, and response time. These all these are very important. See, even this one should be minimum. Even this one should be minimum. See here, maximum throughput, minimum turnaround time, and the response time, the time taken by the process in producing the first response, and this also should be minimum. It should have a minimum response time, it should have a minimum waiting time, it should have a minimum turnaround, maximum throughput and maximum CPU utilization. Sometimes they may ask in math the following. So which one should be maximum or which one should be minimum, or true or false, or multiple choice. Okay. Understand scheduling criteria? Yes or no?
Yes, Mister.
So what are the scheduling criteria are there? What are the scheduling criteria? Different criteria you will prefer. CPU utilization, throughput, turnaround time, waiting time, response time. So while choosing any scheduling algorithm, CPU utilization throughput should be maximum, turnaround time, waiting time, and response time should be minimum. Which one should be maximum and which one should be minimum? See here, the last three should be minimum and the first two should be maximum. Even CPU utilization and throughput, okay, both should be maximum. Okay, so now you should know what is scheduling, turnaround time, what is waiting time, define preemptive scheduling. I'll tell what is dispatcher, everything. Fine. Yeah, actually that one should come at the back. What is dispatcher here? Dispatcher means, someone should push you, right? Someone should dispatch. For example, I'm telling, if you go to the bank, there will be some security guard, right? Security guard. If you
Yes.
go to bank, security guard will be there. When you enter, you will check. Similarly, if you finished your task, he will not allow you to sit inside the bank. He will ask you to go out. Go. Yes or no? Same thing here also. We have the dispatcher. Dispatcher means someone should push. Someone should push. The module of the operating system that provides the control of the CPU to the process, which is selected by the short-term scheduler, is called as dispatcher. Dispatcher means it is one of the task of the operating system. It is like it is having some control of the CPU to the process, control of the CPU to the process. After selecting, so if it is once it is completed, it will come out. Like it will go to terminate, or it will go to waiting state, or it will go to ready state, like that. The dispatcher should be as fast as possible. The dispatcher should be as fast as possible, as it is executed during every context switch. When it is moved from one process to another process, this dispatcher plays a very important time. The time consumed by the dispatcher is known as dispatch latency. So we have the process P1 and we have the process P2. Okay, when process P1 is finished executing, it out and it will bring P1 inside, and it will bring the P2 inside. That time, the gap between P1 out and P1 in, that time is called as what? Dispatch latency. Dispatch latency. The time consumed by the dispatcher is known as the dispatch latency. The model of the operating system. Say, dear, you need not worry about this too much of theory. You know why I'm telling? Because for your midterm, if you concentrate more on your practical, how much mark is for practical? How much mark is for your practical? You don't know? You forgot? Mark is, see, first tell me how much mark is midterm.
20.
20. Okay. So how much in the 20 marks? I need to ask theory as well as I need to ask practical, right?
Yes.
Yes. How much mark is theory and how much mark is practical?
7 marks for
5
theory.
theory.
5.
Yes.
على مسكت. Mr. 5 or 7?
It is 5 here. It is 5. Go through the orientation. I told in orientation how much mark is for theory, how much mark is for practical. It is only 5 mark. It is just 5. So remaining 15 mark, it is very easy for you to get it. You can pass it. If you study only the practical and you know what other things will come in practical also. And I told you, understand? If you want to get 20 out of 20, this theory, all those things is very important. Theory, all those things are very important. Okay. And even for your practical also, you need to practice more. These 15 marks, you will not get it very easily. So these are the very simple things which you know it. Scheduling algorithm, just to have a look. So what is meant by scheduling algorithm? What is meant by scheduling criteria? In scheduling criteria and all, there is maximum possibility to ask define CPU utilization, define throughput, define turnaround time, define waiting time, define response time, or they may ask in multiple choice, or they ask in true or false. They will tell you the response time should be maximum. The scheduling criteria. It is maximum or minimum? Response time should be minimum or maximum? I'm
Minimum is
shouting
there.
minimum. I'm shouting here for 1 hour. Okay. See, given here, which one should be maximum and which one should be minimum? And what is meant by dispatcher? Okay. Now come to the types of scheduling. There are two types of scheduling. One is preemptive scheduling. Dear, why I'm taking some time for this one is because I have the scheduling algorithm. I have the problem. I have the problem. When I start doing the problem, then see here, I have the problem. When I start doing the problem, so you need to know the theory. See here, the problem they are asked. Uh, See here, find the average waiting time, find the turnaround time, all those things they will ask. So you have to know that. That's what I'm explaining on the theory. Okay. So scheduling algorithms. So what is not scheduling? Types of scheduling. Types of scheduling is different and scheduling algorithm is different. Remember, the CPU scheduler performs the task of scheduling and it is a part of operating system. I already keep on telling the operating system has to do some scheduling algorithm. It has to take based on some application. It will choose the different types of algorithm. So here it can be of two types. Generally, it can be preemptive and it can be non-preemptive. See, in the states of the process, we have new, we have ready, and then we have running, and we have terminate, and we have wait like this. So from the new state to ready state to running state to new state, running state to wait state like this. It is there. So there is a possibility from running to wait to ready. Yes or no? Yes or no? If there is any interrupt occur, if there is any IO interrupt occur, then what will happen? The process in the running state will move to wait state and it will go to ready state again. So there is two possibility. Either you will come back or you finish and go. Either you will come back or you will finish and go. For example, I will tell you, you are standing in ATM. You are allowed to use the ATM only for 2 minutes. You are allowed to use the ATM only for 2 minutes. When you are using the ATM, there is some problem. Okay, but you didn't withdraw your money. What will happen? What will happen? The other persons will get the chance, right? The other person will get the chance. What you need to do? Either you terminate or you will come back in the queue, or you will come back in the queue. So it is preemptive or non-preemptive. Preemptive means it will come back again to the process, come back to the process. Non-preemptive means it will not come back. It will not come back. You understand what is preemptive? Preemptive means again you will get the process. Again you will get the processor. Non-preemptive means you will not get the processor. Only one time you will get the processor. You have to complete your task. You have to complete your task. See here, preemptive definition. When the CPU switches from one process to another before its completion, before its completion, then it is called as what? Preemptive scheduling. See, the CPU switches from one process to another before its completion, then it is called as preemptive scheduling. That's what I told you. When you go to the ATM, if there is any problem, you just come out another process. Just come, but you will come back in the queue again. It will come back in the queue. See, in the preemptive scheduling, the CPU can be preempted from a running process and switches to another. So if there is any problem, the process which is in running, it will go to wait. So the process which is there, P2, it will go to running state. When this occurs, the process does not relieve the CPU voluntarily. It does not relieve the voluntarily. So there are two types of scheduling. One is preemptive and non-preemptive. Preemptive means it will come back to the process again. Non-preemptive means it will not come back to the process, it will complete. See here. Preemptive, the CPU executes a process until it is terminated, or until any input output need arise, whether it is completed or not, it will just go. Then such scheduling is called as non-preemptive scheduling. Such scheduling is called as non-preemptive scheduling. So we have preemptive scheduling and we have non-preemptive scheduling. See, why you need to start a new process and start executing another one? There may be some reason. There may be some reason. As I told you, if you are going to ATM, only if you have the problem, you need to come back again. If you don't have any problem, is it necessary to come back again in the queue? No. Likewise, for the process also. For example, some high priority process arrives in the system. Some high priority arrives in the system. So when you are using the ATM, if some old person comes or some ladies comes, what we do? We give priority for them. In such situation, the execution of the low priority process is suspended and the high priority process is executed. Or if there is any interrupt occurs in the process, the child process comes into a parent process. So for this reason, you will have a preemptive scheduling. When you will have the preemptive scheduling, or when it will switch from one process to another process, you have to know the reason. You have to know the reason. What is meant by preemptive and what is meant by non-preemptive. Very simple. See here. P1, P2, P3. We have one process. Finish P1 first. Get out. P2. Get out. P3. Go out. That means P1, P2, P3. Is it coming back again to queue? Is it coming back again in the queue? There, P1 go to CPU, finished. P2 go to CPU, finished. P3 go to CPU and finished. Is it coming back again? Because it
No.
is finished. No, because it is finished. Then it is called as what? Non-preemptive. Preemptive means it will come back. It will come back. From where it will come back? You know the states of the process. You know the states of the process. From the running to ready queue, it will come back. See here, from the running process and switches to another. So I hope you understand what are the two types of scheduling, what is preemptive and what is non-preemptive. Okay. After this, I will take the practical. Scheduling algorithms. What are the different types of scheduling algorithms are there? Some methods use preemptive and some methods use non-preemptive. because generally we classified the types of scheduling algorithm. One is preemptive and another one is non-preemptive. So what is scheduling algorithm? What are the preemptive? We have first come first serve, SJF, priority, round robin. Round first come first serve. Here what will happen? Here you can have both preemptive and non-preemptive. Here also non-preemptive. Here priority means based on the priority. Here also in everything you can have priority, preemptive and non-preemptive. Mostly this round robin is preemptive. The shortest job first you can have both preemptive and non-preemptive. Preemptive and non-preemptive. Here also you can have preemptive and non-preemptive. But here you have only preemptive. It has to come back. That's why the name is called as round robin. What is first come first serve? What is shortest job first? What is priority? What is round robin? So these are the different types of algorithm. So first come first serve, shortest job first. Excuse me. Priority. Anyone tell me what is meant by priority? Priority means with much importance. Priority means what? High important. I'll show you the priority of your process. If you see here, see we have the process. I can change the priority for this. That is the priority. Oh God. Here. What is this? No, in Windows 10 I don't find. I think in Windows 7 and all you can see the priority. You can change the priority to high, low because this Windows 10 maybe it takes decide the priority by itself. Okay. What are the different types of algorithms are there? Priority means high importance. High importance. Okay. So that is called as priority. So when you are in queue in your ATM, I already told you if any old person is coming or if any ladies is coming, we give importance for them. Okay. So the other process which is there in the queue will wait. So what are the different types of scheduling algorithm? In today's class, what you discuss? Just tell me what is meant by scheduling, what is meant by CPU scheduling, the scheduling criteria. What are the scheduling criteria are there? Tell me dear, what are the scheduling criteria? The scheduling criteria is what? CPU, utilization, throughput, turnaround time, waiting time and response time. So you should know which is maximum and which is minimum. And then what is dispatcher, the types of scheduling, preemptive and non-preemptive, and then scheduling algorithms. So now we will see one by one. What is first come first serve, the problem, and then what is meant by, we'll see one by one. Don't worry. These are the four scheduling algorithms are the I think if you go to your lab manual, just check out here. Where is your lab manual? Lab manual, lab manual. If you see this one lab manual, so we completed the first part. Your scenario is over. We will see the cell programming later. Okay, cell programming later. We'll see it. Now come to scheduling algorithms. So this page number 14. Page number 14. We'll see that one. Scheduling algorithm. So these are the problems we'll see, and I'll discuss here, and you will work out. I'll give you a break for 5 minutes. Okay, because I need the break. Is it fine?
Yes, it's
Fine,
fine.
Mister.
Fine.
Yes,
Oh my
Mister.
God! Now with so many voices. When I ask questions, no one is answering. No, I need break because continuously talking for more than 1 hour it is very difficult.